Hi everyone, so today we will be solving LeetCode 3823. It's called the reverse letters, then special characters in a string. So in this question, we are given a string S having lowercase letters and special characters. And we need to reverse the lowercase letters and place them back into positions occupied by letters, and same for the special characters. And we need to return the resulting string after performing the required reversals. So what the question is saying is that suppose we had a string like A hash B star, and our result would be C. If we would have simply reversed it, like basic reverse what we do, so we would have got star B hash and A. But here we do not need to do in this way. What we need to do is, let me index it also. So here we need to reverse the letters separately and special characters separately. What I mean by this is, suppose we first see our original string. At 0th index, we got a lowercase letter. So whatever is the nature of the character in a particular index, that same nature would be in result also. Which means, suppose here at 0th index, we have lowercase letter, right? So in result also at 0th index, we would have lowercase letter only. But this is not the case in a normal reverse. So at zeroth index, we are sure that we would get lowercase letter only. And which letter we would get, that we will determine by traversing in backwards direction in the original string itself. So when we traverse in the backward direction, first we get star, which is not a lowercase letter, so we skip it. Then we get B. B is indeed a lowercase letter, and we have not used yet in our result, so we would B. So I hope it's clear. Then we have done for A. Then we move to hash. Hash is a special character. So that means in result also at first index, we would definitely get a special character only. And which special character we would get, that we would determine by traversing in the backwards direction in the original string. So when we traverse backwards, first we encounter this star and it's not used yet, so we put star here. Then we have done hash also, then we go to B. B is a lowercase letter, so we are sure that index 2 would also have a lowercase letter. And which lowercase letter it would have, that we would know by traversing in the backwards direction. So first we encounter star, it's not a lowercase letter, so we directly skip it. Then we go to B, it is a lowercase letter, but it's already used, right? Here at 0th index. So we skip it also. Then we get hash, it's not a lowercase letter, so directly skip. And finally, we get A. A is a lowercase letter and also is not used in our result yet. That's why we put A here. Then finally, we reach star. Star is a special character. So at index 3, we are sure we would get a special character only. And which special character we would get? We traverse backwards and we will find that star is already used here, right? So we would get hash. So hash would come here. So this is our resultant string. Let me try run on this example as well, so things will become more clear. So indexing it, we would get 7, 8, 9. So result would also be 0 to 9, that is 10 positions. 4, 5, 6, 7, 8, 9. So let me again try run for this example as well. So first we see go here. Here we have a closing round bracket. So it's a special character, right? So we are sure in result also 0th index would have a special character only. And which special character it would have, that we will determine by traversing backwards in original string. When we do so, we first encounter this, and this is indeed a special character. So we use it. And at 0th index, we put this. Then we go to E. E is a lowercase letter, so that means in result also here I would get a lowercase letter only. And which lowercase letter I would get, that I determine by traversing backwards, because we have to reverse, right? So when we traverse backwards, we first encounter this. This is a special character. but we need a lowercase letter, right? So we skip it. Then we go to I. F is indeed a lowercase letter and is not yet used in our result also, so we use it. Next, we come to B. B is again a lowercase letter, so we again search for lowercase letters from backward direction. So when we do so, this is skipped because it is a special character. We then come to F. F is a lowercase letter, but it's already used here, so we skip this as well. Then we get at the rate. It is a special character, but we want lowercase letter, so we skip this also. Then we get A. A is indeed a lowercase letter, and it's not yet used in our result, so we put A here. So similarly, we build our entire string, and we would get this as our final string. So I hope the question is clear. So I would be discussing the approach to solve this. So let's come to the approach of solving this. So now what I'm going to tell is I want you all to listen very carefully because this is the main, crux of the problem. So since in this question we have to deal with letters separately and special characters separately, that is we need to reverse them separately. So we would take two strings, namely letters, or you can name it whatever you want, and special. I am naming it these only. In letter string, what we would have? We would have all letters. So all letters is E, B, C, D, A, F, right? And in special, we would have all special characters. So they are hash at the rate opening parenthesis. So we would create these two strings and let me write them here again. E, B, C, D, A, F, and special is this one, right? Let me index them as well. 0, 1, 2, 3, 4, 5, 0, 1, 2, 3. And let me write the original string also. C hash D A F and index it as well. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So result is also 10 letters. 3, 4, 5, 7, 8, 9, 10. Perfect. So what we would do is now we traverse our original string. So we first come to this. At 0th index, we find that we have a special character. So we are sure in result also at 0th index, we would have a special character only. And which special character we would have? So since we will only have special characters, we would check this special string only because we are not concerned with the lowercase letters, right? Since we are searching for special characters only. So you would take two pointers. Suppose this is J and this is K. And both will be pointing to last let characters of both strings because we want in reverse order, right? So we would go from last to first. So since 0th index has special character, so result also would have special character at 0th index. And which special character it would have, that would be pointed by K. And K is pointing to opening round bracket. So we put opening round bracket here. And since we have now used it, we would move the K pointer backwards. So now K points to index 2. So I hope you are getting what I'm doing. So next we move to E. E is a lowercase letter, right? So this time now we would check this letter string, not the special string, because we are searching for lowercase letters now. And what letter we would put is the one that is pointed by J. So J is pointing to F, so you put F here. And since now we have used F, so we would move the J pointer backwards. And now it points to index 4. Again, we move further in the original string, we get B. B is a lowercase letter, so we would check letter string only. And which letter we would put? The one pointed by J. J is pointing to A, so we put A here. And since we have put A, so we move the J pointer backwards. Again, we get C. It's again a letter, so we again check the letter string only. J points to D, so we put D here and move J backwards. Then we encounter a hash. So now hash is a special character. So now we would not check this letter string. We would in fact check the special string. And special string, the one pointing by K is at the rate. So we put at the rate here. And now since we have used at the rate, we move the K pointer backwards and it points to index 1. Next we get D. D is a lowercase letter. So now we check this letter string and J is pointing to C. So we put C here and since we have used C, so we move J pointer backwards by one position. Next we get A. A is again a lowercase letter. So we C. J is pointing to B. So we put B and since B is used, we move J pointer backwards. Now we get at the rate. At the rate is a special character. So we go to the special string. At special string, K is pointing to hash. So we put hash. And since we have already now used it, so we move the K pointer backwards. Then we get F. So F is a letter. So we go to the letter string and J is pointing to E. So we put E. And J was 0. So now J becomes -1. So after that, the last character is opening round bracket. This is a special character, so we put to the special string, and in that case pointing to closing round bracket. So we put that, and since we have used it, we move k backwards. So k was at 0, now k becomes -1. So like this, you would see that we would build our entire result. So what we did nothing but we just checked if our index has a lowercase letter, we go to the lowercase letter string. And if it has a special character, we go to the special string. Also, we put that character which is pointed by the J or K pointer in whichever string we are going. And once we put that character, we just move the J pointer or K pointer backwards by decreasing by 1. So in this way, we would build our required result in the reverse direction. And as you can see, we dealt with letters and special characters separately. That's why we got our desired output. So let me write the code also so things would become more clear. So coming to the code of our approach, so we have to return the resultant string and we need to return a resultant string and we have a given string s. So as I told you, we create two separate strings, letters and special. So we check the entire array, entire string, and for each character we check if it's a lowercase letter. This condition checks whether it's a lowercase letter or not. If it's between small a and small z, which it means it's a lowercase letter. So we add it to the letter string. Else it's a special character, so we add in the special string. And then we take two pointers, j and k. J points to the last character of letter string and k to the last index of special character string. Then we traverse the entire S string and we extract each character. If that current character is a lowercase letter, then what we do is uh, we also take a result string. So if it's a lowercase letter, what we do is in result we add that letter in the letter string which is pointed by the j index, and once we use it, we decrease j by one position. This is postfix, right? And I have told you what it does. It first uses the current j value, and after using it, it decreases it by 1. So that's exactly what we are doing with this postfix operator. And similarly, if the character is not a lowercase letter and it is a special character. So we go to the special string and we use the one that is pointed by k and we add it to our result and then we decrease k by -1. And finally, we return our result string. So coming to the time and space complexity, since we are traversing the entire original string, time complexity is big of n, where n is the length of the original string. And space complexity, suppose our letter string is taking it has suppose x characters and special has y characters. So additional space we are taking is big O of x plus y, that is space occupied by the letter string plus space occupied by the special string. And we know that the letters and special string we are only making by forming by our original string. That means x plus y would always be equal to the string length, say n. So space complexity is nothing but space taken by the letter string, that is x, plus taken by the special string, that is y. And x plus y is nothing but n, because this letters and special string is only being made from the original string only, and from nothing, nowhere from else. So that's why it's big of n only. So time and space both are big of n each. See, actually, time complexity would be n square since we are taking result string and string is actually a immutable data structure. That means whenever we suppose we have a string, suppose A, and later we decided to add B in our string. So the change would not be done in the original string itself. This would not happen. Suppose we had A, right? So what will happen in memory is another copy of it would be made and the change would be done on that. So when we do updations in a string, we do not edit our original string, rather we create a separate string every time we do a modification. So this is why strings are memory-wise inefficient. So that's why n square is the real time complexity, which is not that good. But since we have not discussed those concepts yet, we can consider this as big of n. Later, I will be making videos on string and string builders also. So then concept will become more clear. So this was it for today's video. And I hope you liked the question and the approach and understood the code as well. So thank you so much for watching, and I will be making more such videos. Thank you.